Hi everyone, it's Mr. Wilson again. We're going to do some Chapter 6 homework problems. I picked out 4, so let's see what we can do. Alright, I'm starting with question number 2. Student was asked to find a 95% confidence interval for widget length using data from a random sample of size n equals 29. Which of the following is a correct interpretation of the interval 10.6 is less than mu is less than 33.7? So that would be our confidence interval from 10.6 to 33.7. All right, so I see the first choice starts with there is a 95% chance, and we can automatically eliminate that because probability doesn't really apply to the situation, to a confidence interval. A probability is something that may happen in the future. So when we are talking about probabilities earlier this semester, we're talking about the chances of an event happening or not happening. So we have these widgets, they exist, they all have a width, they're all measurable, and the actual population mean of these widget widths, that's hard to say, exists. It's already a number. There's not a probability that it's between something and something. It is what it is. It exists already, and a probability does not apply there. So we're going to eliminate. Let me get my trusty pen out here. Why is that not working? There we go. We're going to eliminate the first one and the last one because we're not going to say that a probability applies to the situation. All right, I'm looking at that middle one as well. It says the mean width of all widgets is between 10.6 and 33.7 95% of the time. That makes no sense. So the mean width is a number. It's not a number 95% of the time. It's a number 100% of the time. And it's either between those two values or it's not. So the middle choice does not make any sense. So we're down to these two choices that start with 95% confidence, and that's how we want to write our interpretations of confidence intervals. So it does sound kind of subjective, like what does it mean to be 95% confident of something? What's the difference between saying you're 95% confident and you're 98% confident or 80% confident? When we're dealing with these confidence levels, you'll see a different percentage pretty much for every problem. Well, when we say that we're 95% confident about a confidence interval, what that means is if we were to repeat this process or this experiment over and over again, if we're able to take these samples of size 29 over and over again, good representative random samples from this population, we take these samples, we calculate sample mean of the widths, and we record them. So we have all these means of our samples. We would expect about 95% of them to fall between our values in our confidence interval, 10.6 and 33.7. So if we were dealing like an 80% confidence interval, that means only 80% of the samples we would expect to be between our endpoints of our confidence interval. So that's really what we are talking about when we're dealing with the language of the interpretation. All right, so we have to pick one or the other. Either the mean width of all widgets is between those two values or the mean of a randomly selected widget. Well, when we're doing confidence intervals, we are making an assertion or we're making an estimation about the population mean. So that's the mean width of all widgets between 10.6 and 33.7. So I'm going to choose this fourth choice for my answer and eliminate all of the others. All right, scrolling down. Next one is number 11. So, a confidence interval for the population mean length of hit songs was found to be 4.5 to 5.6 minutes. Find the midpoint of this confidence interval. So, the midpoint of a confidence interval is always what's called the point estimate. And the point estimate is just what you found from your sample to be, in this case, the mean length of a confidence interval. So the way we find a midpoint of two values is just to average them. So to average two numbers, just add them together. 4.5 plus 5.6 is 10.1 divided by 2, and that's 5.05. So my midpoint is 5.05, and my confidence interval in the form of X bar, which is the sample mean, that's our point estimate, plus or minus the margin of error. So the margin of error is just the distance between that midpoint and one of the two endpoints. So it doesn't matter which one you find, since it's smack dab in the middle, it's going to be equally we're equally able to calculate it from one end to the other. My computer's telling me I need storage space. So I'm just going to take the upper limit, 5.6, subtract my midpoint, 5.05, and that gives me 0.55. Little pointer is hard to write with, but I think we get the gist of it. So my confidence interval in terms of, let me make that a little better. X bar plus or minus the margin of error is 5.05 plus or minus 0.55. Moving on. Now we're going to do a couple of examples of just actually calculating our confidence interval. We'll do one for proportions and one for means. The formula for these are very, very difficult to do by hand, so we're going to be relying on technology, just like we have several other problems in this course. For number 13, we've got a random sample of 318 people that were tested for norovirus. It was found that 251 did not have the virus. Construct a 91% confidence interval to estimate the proportion of the population that does not have the norovirus. So on this one, there's a drop-down menu to select the correct symbol for our confidence interval. In this case, our estimation, we're making a claim about the population proportion, and a population proportion is just the lowercase p. The one that has the p and the little hat on top, that's the point estimate, which is the sample proportion, but we can calculate that. It's just 251 out of 318. The population proportion is what we're making an estimate of, and we're going to estimate that it's between two values that we find using technology with 91% confidence. All right, so let's go to our calculator.